What we're looking at today is the last section of DMA 70. This is section 8, and section 8 is about rational functions. Just a few tidbits about functions. A relation is a function in which each x has exactly one y coordinate. So each x has only one y coordinate. So there's only one answer for every x. A function notation is, if you think back to DMA 50, we had like y equals x plus b for a linear equation. When we do function notation, we write f of x equals mx plus b. So what we do in function notation is we substitute the y with, wait a minute, we substitute the y with f of x. That way, when you have your answer, you have f of x, and then the answer on the right side is technically the y. So you could take the information from function notation, and you can actually write an ordered pair where this value is the x, and then this value is the y, once you've actually solved. When we talk about the domain of a function, the domain is a set of real number values that can be used for the x. So the domain of a function, those are these. The domain consists of all real numbers except for those that make the function undefined. So your answer is all real numbers except what makes it undefined. And with a rational expression, if you recall what makes it defined is, you want to ask yourself, what makes equal to 0? And those are going to be the exceptions that we're looking for when we are finding the domain of a function. So if, for example, I give you this equation, this is my function, and I have x minus 2 in the numerator, and let's say x squared minus 10x minus 24 in the denominator. So if I have this and I want to know what is the domain is going to be all real numbers except. Now in this case, all we have to do is factor the denominator, and you could use your calculator to go about doing the factoring. And in this case, when we factor this into two terms, we end up with an x minus 12 and an x plus 2. So our solutions of what would make this equal to 0 would be the answers of a positive 12 and a negative 2. So our answer is going to be all real numbers except 12, and those will be the two exceptions. If you have a problem that looks something such as this, let's say our function for this one is f of x equals x plus 9 over x squared minus 81. What we're going to do first is we're going to factor the denominator. And if you notice, this denominator happens to be a difference of squares. So we're going to factor this to be an x plus 9 and an. So we would have a solution of all real numbers except what would make this first denominator, this first factor, equal to 0 would be -9, and what would make this a 0 would be a +9. If you had a function, let's say in the denominator there is no variable, then your solution is going to be all real numbers, there are no exceptions. So if no variable in the denominator, then it would just be all real numbers, and again, and there would be no exception to that. You will have a practice problem, an application problem that you're going to do with a cost function. And with the cost function, I'm just going to call it the mountain bike problem. And you'll have one like this that you'll be doing on your test. And for the mountain bike production, you were told in the problem, let's say, that it costs $400,000 monthly for the overhead cost to run the business. And then they may say it costs $200 in parts per each bicycle. So when you're asked to write the cost function, the C of X, that's going to be, there's always the $400,000 a month, and then it would be $200 per bicycle. That would just be, in general, what's called the cost function. When you're asked to find the average cost function, when you write C of X, they're going to draw a little line above the C. For the average cost function, you're still going to use the 400,000 plus 200x in the numerator. However, since it's the average, we're then going to divide it by the number of mountain bikes. In this particular problem, what they're going to start with is they're going to ask you the average cost function for, let's say, 500 bikes. They may ask you the average cost function for 1,000 bikes. Well, excuse me. Erase that. I didn't write it correctly. So if we do the cost for 500, when we do the cost for 1,000, we want a solution. We would then be asked what is the average cost function for, let's say, 1,000 bikes. And then let's say the average cost function for 5,000 bikes. So as you're doing this and you key it in on your calculator, you can do one of two ways. Either you can use a parenthesis when you type it in and put a parenthesis around the entire numerator and then divide it by when you see the division part. Or you can type in the whole top row, press enter, and then do divided by x. Okay, so let's do this. So if I have $400,000 plus 200 times 500, I typed in the entire first row. I could then press enter, and then I still need to divide by the number of bikes, which was 500. That'll give me $1,000 per bike. So the first answer, let's do the average cost for 1,000 bikes. So 400,000 plus 200 times, press enter, and then we're going to do divided by 1,000. And that gives us an average cost of $600. Now I'm going to show you the same thing, but I'm going to type it in using the parentheses for the cost of the 2,000. So if I want to use the parenthesis, I would do the 400,000 plus 200 times 2,000. Use a parenthesis to close in the entire numerator, divided by the total number of bikes, which is 2,000. That gives us a cost of $400 per bike. And then I'm now going to do 5,000 bikes. And I'll use the parenthesis again for this one. So you can see there's two ways that you could key this in. So 400,000 plus 200 times 5,000, close your parenthesis, divided by 5,000. Oop, too many zeros. And that gives us a cost of $280 per bike. So what do you notice about the cost of producing the bicycles? The more bicycles you produce, when you go from 500 to 1,000, the price drops by 400. Then when you double it to 2,000, the price drops to 400. When you produce 5,000, it goes to 280. Something that we're going to be looking for that you may be asked about is also going to be what is the asymptote of this equation. So what's going to happen is if it costs $200 for materials per each bicycle, and if we always have to divide this $400,000 overhead cost per each bike, the more bikes you produce, this 400,000 gets split among a lot more, so you have a very little cost. It might even be a fraction of a cent. But what we're going to do is you'll see the price is going to decrease and decrease and get closer and closer to 200. But it's never actually going to reach the 200. So in this case, my asymptote is going to end up being a y equals equation, and it's going to be the value of what the number for the parts for the bike would be. So that's similar to a particular type of problem that you're going to see, I do know, when you're doing your testing on function notation. Most everything else is just factoring the denominator and determining what would make it equal to 0.